Okay, so today what we're going to do is take a look at the work that people did on the Jamboard. I'm going to look through it with you, and then after each one, I'm going to ask at least one question for you to answer. Okay, so take a moment to read this one. The length of a photograph is 3 centimeters, less than twice the width. Okay, so Emma and Libby decided to use W for width. That's a great idea. Okay, so if we make our rectangle, W for width, and 3 centimeters less than twice the width is the length. We can correctly see here that they have written an equation. Okay, actually solving it, it looks like 2 different ways. Okay, one by completing the square. Okay, one by using the quadratic formula. Okay, and my question for you, so either way, they ended up with a solution of 7 and a negative value, which didn't make sense in this problem. Okay, so their dimensions are that the length is 11. Of course, in this case, that would be centimeters, and the width is 7 centimeters. Okay, and so my question to you today is, what is the discriminant shown in their work here? Alrighty, so let's take a look at this one now. Okay, a lot of work typed up for us. Okay, and yeah, I know this is one of the pitfalls of the Jamboard. Without a stylus or some sort of device that you can really write on, it's a little bit difficult. Group made a great effort at drawing what the situation was though, right? So we have a rectangle that starts out, and it's the garden that's 7 by 12. Okay, and each dimension's increased by some amount, x. Okay, so here's that increased amount, each dimension. Okay, and the garden now has an area of 126. So this is a great example of a problem that actually has a whole number solution, and guess and check is probably the most efficient way to do this. But I did ask that you use your quadratic equations to do this, so let's just kind of follow through. Okay, so Ian starts out that saying that the area can be represented by x plus 7. Okay, this side multiplied by this side. He's absolutely correct, right? He multiplies that out to get this equation. Okay, then kind of somewhat miraculously and by magic, he gets that x is 2. Okay, no real evidence on how he got x was 2. Of course, there should be another solution probably here too, although it may not be a valid answer. So let's take a look at what Isaac added, right? If we read through all of Isaac's work too, he kind of gets to the same point here that Ian did. Okay, and he set his equal to 0 and then used the quadratic formula to get 2 answers, but explains why only this one makes sense. Okay, I want you to take a moment to look at Elias's work now in the green. I like how they color-coded theirs, right? Okay, and I want you to read this first box, and I'm going to pause the video here and ask you a question where you can comment appropriately, okay, to help Elias understand what he should have done first. All right, let's take a look at this one together. So someone launched a model rocket with an initial speed of 88 feet per second. Okay, after how many seconds will the rocket be 40 feet high? So Julie and Hannah correctly wrote an equation here to model this. Okay, I love this. They multiplied by -1 and then added 40 to each side. Okay, just don't forget that you do still have an equation here. So this is equals 0. I'm just going to add that in because I don't want to think that we can solve an expression because we can't, right? This is equal to 0. This was nice when this factored nicely, so we didn't have to use the quadratic formula, right? And they have the answers here. So I'm going to pause the video and ask you to answer the question. To write this solution is a solution sentence, please. All right, here we have another nicely done problem. Okay, so we have a pool that measures 4 yards by 5 yards. Not a very big pool, right? Okay, and we have a deck constructed around the pool. Okay, the total area is 90 square yards. Okay, and so your classmates here started out by saying, of course, X is the width of the deck because they defined what it was shown here in the picture. Okay, and then they wrote the equation in factored form. Okay, saying that, well, this side must be 4 plus 2x, and this side must be 5 plus 2x. Right, and then they correctly figured that out, set it equal to 0, used the quadratic formula, came up with their answers, and said that the answer had to be 2.5. Okay, they did a fabulous job. Not much more I can say. So what I'm going to ask that we do today is, because they got a rational solution, I know this actually could have been done by factoring. And so I'm going to ask that we take a moment here to take a look at that and how we would have done that. I'm a little short on space, so I'm going to speak through some of the things I'm doing. So I am going to divide everything by 2 because I see I have even numbers, just to work with something a little bit easier. Okay, and I can do that since I have an equation, and I can do it to both sides. I can change the problem without changing the solution. Okay, and this is a little tricky to factor, so I thought we would go through it again. Okay, so one thing we do is we take the 2 and the -35, we multiply those together, we get -70. We think of numbers that multiply to make -70, but add to make +9. Okay, after a little bit of thought, I'm going to think about that. That would be 14 and -5. They're factors of -70 that add to make 9. All right, so I'm going to write 2x squared. I'm going to rewrite my 9x to be plus 14x minus 5x, so rewriting that 9x, minus 35 equals 0. Okay, and then you're going to go ahead and split this, right? Okay, and you're going to do 2, let's say 2x times x plus 7 minus, let's see, I need to get an x plus 7, don't I? All right. So now when I pause the video, I'm going to ask you to tell me what the factors of 4x squared, or actually of 2x squared plus 9x minus 35 are. Please tell me what the two binomial factors are. All right, taking a look at this nice work here. The dimensions of a rectangular flower garden were 8 by 15. Okay, that was the original garden, right? This nice picture here drawn up. Each dimension was increased by the same amount. This time, kind of like one of the previous ones, we just add the x this way, not in each dimension necessarily, equals 198. Okay, because this answer is rational again, here's another example of where solving this by guess and check would have been very quick. Okay, but I asked you to do it by using quadratic formula, and Will did that. Okay, so once again, this side is x plus 8, and this side is x plus 15. Okay, they have their equation correctly written here. Multiplying it out and putting it in standard form, they end up with this equation. Okay, they solved it by completing the square. Great strategy. Okay, what I'm going to ask that we do this time is, okay, that you think about how you could do it, because once I know the answers are rational, right, I actually know that I could have solved it by factoring. So I'm going to stop the video here and ask you to take their equation that they ended up with and set it up so that you can use the zero product property, and go ahead and try to come up with the factors of that, please. All right, so here's another question, and we can kind of see a pattern here of similar type problems, but here we have a 7 by 10 picture frame. Again, the side lengths are being increased by x. Okay, so Nico and Declan clearly noted that their equation for the area would be that this one side is 7 plus 2x, right, and the other is 10 plus 2x, and the product of those two would have to be the 130 that we're told in the problem. Okay, and they did a great job here. Again, limitations of Jamboard are that without a stylus, it's very hard to write on, right? But they used the quadratic formula, and they used it very correctly, it looks like, okay, very accurately to do that problem. Okay, they came up with a discriminant of 2,116, which of course is a perfect square. Not of course, you'd probably use your calculator to find out that of course it is. All right, so I just want to, for this problem, think about the numbers and what they would have been had we realized or thought about the fact that they were all divisible by 2. Okay, so if I were to divide this by 2, I would have 2x squared plus 17x dividing by 2 here, minus 30 equals 0. Okay, so my question then would be, what would the discriminant be if I use this equation instead of the one that was multiplied by 2? Okay, and if you choose, you might just want to verify that that the answers are the same either way. Okay, I was just reading here, x equals 1.5, okay, and then kind of comma, the frame is 1.5 inches wide. So I got a little sidetracked there. So I'm going to pause the video here. I'm going to give you a chance to go ahead and figure out what the discriminant would be for this quadratic, and go ahead and answer that question, please. All right, so here we have a problem. The length of the rectangle is 4 more than the width. Okay, so we have an equation. We didn't quite define the variable here. Okay, so either in our picture, so x times x plus 4. So it looks like the width was x and the length was x plus 4. So just to clarify that up, right? And I love how people are using the completing the square very fluently here. So made that a perfect square trinomial, factored it. Okay, one of the, when we square root both sides, we get the square root of 34 here, right, which is about 5.8. X plus 2 is got to equal 5.8, so x is 38. Okay, so I like all of that. I want us to think about this for a second. Okay, although it turns out it does give us 7.8, okay, which is exactly 4 more than the 3.8, it is not actually 7.8 that is a solution to this original problem. Okay, in fact, if we think about it and we put in, if we tried to test it, for example, 7 8/10, 7 8/10 plus 4, okay, equal to 30. This is a test. Okay, we can go ahead and see, right? This is just doing a little estimating. This is more than 11. 11 times something that's close to 8 is not going to be 30. Okay, so that tells us 7.8 isn't actually a solution. So for your question here, I would like you to please explain what this should have been and what the other solution to the quadratic actually is, and why that isn't a valid value for x anyway, so we're only going to use the 3.8 for x, okay, and then add 4 to that, which is going to come to 7.8, so that's all correct. Okay, but just let's take a moment to explain to our classmates why that's not correct. All right, for our final question, let's take a look here. Mr. Lumen replaced a square window with a rectangular one. The new window is 3 feet wider, 2 feet higher than the square one, has an area of 42 square feet. How long was the side of the original window? All right, so it looks like here's our original window. Okay, let's think about this for a second though in this picture. Was he kind of building a frame around the window? Okay, was he adding 3 feet on each side? I don't think so. Okay, so I think our picture really might need a little bit of revising here. Okay, so it looks like that's his original window, right? And this is his new window. All right, which is x plus 3, right? X plus 3 multiplied by x plus 2 this side. All right, so just fixing up that picture a little bit more so it clearly denotes what's happening. But this is an example of some really awesome work, making an attempt to write on the Jamboard a little bit here. I know it's not easy, and this print is really nice and clear, so that's awesome. They multiplied the x plus 3 times x plus 2, had to equal, I think this should have been 42 here, but they, okay, correctly got it in here, and then subtracted. Solve by factoring. Love that you could do this by factoring, right? We can do this one using the quadratic formula, which is shown here. That's correct too. The only way they didn't do this one was by completing the square. So let's go ahead and just think about that. I don't think we would have wanted to do this one by completing the square. It doesn't seem like that would be the easiest way to do it. But just for practice, if I had taken this equation and said x squared plus 5x, okay, plus something equals, we'll put that 36 on the other side, okay, go ahead and tell me what that should be to complete the square. Okay, and if you want to go ahead and solve it that way, you certainly may, but you're not required to. And that wraps up our review of our classmates' work. So, and my first attempt at an ed puzzle with you. My second attempt totally, because I did one with the geometry class this morning too, and I did make a little bit of a mistake with theirs. Hopefully this goes better. All right, I welcome any feedback you have to give me about this this tool or this video or anything at all, and I hope you have a great day. Bye.